So I'm a popular teacher. What can I say? I wasn't able to finish and show you the last step on the last one. So to your bonus, I'm going to go ahead and do the first try this 5-7C with you so that you don't have to do 6, but you'll have to do 7 on your own. Blah, ha, ha. So looking at this, let's go ahead and I'll write it out. You can copy, and there'll be an answer correct for you, assuming I get it right. Okay, so looking at this one here, we see, I'll start this one. We see that x is 3, so x is 3, but what do we put in between? Well, we notice that it's a jagged line, and we notice that the truth is going less than 3, so x is less than 3. Looking at the second equation, or inequality I should say, you can see it's a jagged line again, and then if I were to find the b, it looks like the b is at 1, 2. So the b is going to be 2. Remember that whole y equals mx plus b? Well, the b is 2, the y-intercept. It looks like we're going down 1 over 1, down 1 over 1, so the m would be a 1. So y something not equals 1m x plus 2. But is it, what do we put instead of an equal? Well, it looks like the answer is less than. It's going down. See how the truth is in here? So it'd be is less than. So y is less than mx plus mx plus 2. But it's a negative slope, so I should need to put my negative in there. So if it's just a 1 over 1 for the m, you don't even have to write 1 over 1. You can just write, well, y equals negative x plus 2. Again, the negative is there because we're going down 1 over 1, down 1 over 1. When you go down, it's negative. Okay, so we have our two inequalities right there. And that's as far as we got last time. Then I got rudely interrupted. So what we're going to do this time is check it. And that's the last step of this, is to go ahead and check it by choosing any point you want. You can choose something from the true side or the false side to check it. I'll choose something from the true side this time. I'm going to choose a -2, -2. That would work. You can choose anything. I'm just choosing these because they're in the shaded area. Okay, so if I were to put in a -2 for the x here, because x is a -2, because I chose it to be so, is -2 less than 3? Yes. So this is true for this. And then let's try the second inequality. Instead of a y, I'm substituting in a -2. Is that less than a negative? And then for the x, you're putting in a -2 plus 2. Is -2 is less than a 2, positive 2 plus 2, or is a -2 is less than 4? Yeah, that's true. A -2 is less than 4. So you see that this test point of -2, -2, when I substitute them in, comes out for both of them. Okay, you can copy that one, but you need to do this one on your own. So go ahead and try this 5.7, question number 7. Okay, last question is this application problem. It's using algebra in the real world. It's Mr. Evans, how do we ever use algebra? Well, something like this. You have at most 8 hours to spend at the mall. Now, this at most should be a big clue because at most is always represented by is less than or equal to. So you have at most 8 hours to spend at the mall and the beach. You want to spend time at the mall and the beach. Okay, so we can already kind of see the variables here. Time at the mall, time at the beach. You have at most 8 hours. So we can already write something like x, the time at the mall, plus the time at the beach. It's going to be less than or equal to the total amount of time you can spend, which is 8 hours. You want to spend at least 2 hours at the mall. So the time at the mall, which we'll call x, is at least 2 hours. So a great way to represent that would be something like x is greater than or equal to 2. Time at the mall is at least 2 hours. And more than 4 hours at the beach. So you want to at least spend 2 hours. You want to spend more than 4 hours at the beach. So y is greater than 4. Okay, so we actually have 3 inequalities here. That's great. So we just need to graph these three, and we will be done. So it's okay to graph all three onto the same ordered pair. They're all three part of the system. So what do we have? X plus y is less than or equal to 8. X is greater than or equal to 2. And then what was the third one? Y is greater than 4. Whoa, we didn't see any of that. Here it is. Okay, so this one is easily graphed using the intercepts. You can also solve for y, but let's just use the intercepts. If x is 0, you don't go anywhere. Y is 8. 1, 2, 3, 4, 5, 6, 7, 8. If y were 0, we'll do the x-intercept. X would be 8. 2, 3, 4, 5, 6, 7, 8. Okay, is the line going to be jagged or straight or solid? It's going to be solid because it's less than r equal to. Just solid line. There we go. We have our boundary line right here. And then the second one is x is greater than or equal to 2. So go to x is greater than 2. Okay. So go x is 2. It's greater than or equal to. So again, a solid line. Whoops, I missed it. There we go. And y is greater than 4. So go to 4. Okay. And then as I'm going through 4, notice that it's just greater than. So it's not a solid line. The boundary line is not included as part of the answer. So what area do the all three have in common? We can tell by a test point. But you can kind of tell by looking. Y is greater than negative 4. So if you had this, or 4, so if you had y is 4, it's more than that. The all of this. X is greater than or equal to 2. So you go to 2 and it'd be going this way. Use a different color marker. And then if you try a test point here, you can determine for this line which side you would go on. I'm just going to choose 0, 0 for my test point. Is 0 plus 0 less than or equal to negative 8? Yeah, it's true. So that 0, 0 is less than or equal to negative 8. So you would, since it's true, the 0, 0, you would shade in this side of the other line. Okay. So what do all three of these have in common shade? It's this little area right in here. They all hit that. And so that is the answer. This is the whole time span of the different options you could spend at the beach or at the mall.